According to the 2002 National Electrical Code Section 430.58C5, which addresses receptacles for motor-operated appliances, specific requirements are outlined for ground fault circuit interrupter protection. It states that all 15 and 20 amps, 125 to 250 volts receptacles installed in dwellings, and all 15 and 20 amps, 125 volts receptacles installed elsewhere that are intended for cord and plug connected motor-operated appliances of 1/3 horsepower or greater rating, and all 20 amps, 250 volts receptacles shall have ground fault circuit interrupter protection for personnel. Based on this specific section, there is no requirement for ground fault circuit interrupter protection for a 30 amps 208 volt receptacle single-phase circuit. This section primarily focuses on 15 and 20 amps receptacles operating at specified voltage levels and used with motor-operated appliances. However, it's crucial to understand the broader context of the National Electrical Code and consider other applicable sections that might influence the installation requirements for this type of receptacle. Firstly, it is essential to verify the specific use case of the 30 amps 208 volts receptacle. If the receptacle is intended to serve motor-operated appliances, even though it exceeds the amperage rating mentioned in section 430.58C5, it is prudent to evaluate the potential benefits of ground fault circuit interrupter protection for personnel safety. Secondly, consider the location of the receptacle. Receptacles installed in specific environments, such as wet or damp locations, healthcare facilities, or construction sites, may have additional ground fault circuit interrupter protection requirements as mandated by other sections of the National Electrical Code. Thirdly, assess the overall electrical system design and coordination. The installation of a 30 amps 208 volts receptacle should be integrated into a comprehensive electrical plan that considers factors such as overcurrent protection, grounding, bonding, and voltage drop to ensure safe and reliable operation. Fourthly, refer to local amendments and regulations. Local jurisdictions may have adopted amendments to the National Electrical Code that impose additional requirements or exemptions for ground fault circuit interrupter protection. It is imperative to consult with the local electrical inspector or authority having jurisdiction to ascertain compliance with all applicable codes and standards. Fifthly, evaluate the risk assessment. Conduct a thorough risk assessment to identify potential electrical hazards associated with the use of the 30 amps 208 volts receptacle. Consider factors such as the likelihood of ground faults, the potential for human contact with energized parts, and the severity of potential injuries. The risk assessment can inform the decision-making process regarding the necessity of ground fault circuit interrupter protection. Sixthly, explore alternative protection methods. If ground fault circuit interrupter protection is not explicitly required by the National Electrical Code or local regulations, consider alternative protection methods such as equipment ground conductors, bonding jumpers, and overcurrent protection devices to minimize the risk of electrical shock and equipment damage. Seventhly, prioritize personnel safety. Always prioritize the safety of personnel who may interact with the electrical system. Even if ground fault circuit interrupter protection is not mandated, consider implementing additional safety measures such as regular electrical safety training, the use of personal protective equipment, and the establishment of safe work practices to prevent electrical accidents. Eighthly, document the decision-making process. Maintain detailed records of the decision-making process, including the rationale for the installation of the 30 amps 208 volts receptacle, the assessment of ground fault circuit interrupter protection requirements, and the implementation of any alternative protection methods. This documentation can serve as evidence of due diligence and compliance with applicable codes and standards. Ninthly, seek expert consultation. If uncertainty exists regarding the interpretation or application of the National Electrical Code, consult with a qualified electrical engineer or other subject matter expert to obtain professional guidance and ensure compliance with all applicable requirements. Tenthly, stay informed about code updates. The National Electrical Code is revised and updated periodically to reflect advancements in technology, changes in industry best practices, and lessons learned from past electrical incidents. Stay informed about the latest code updates and revisions to ensure that electrical installations are in compliance with the most current requirements. Regarding instantaneous strip requirements, the National Electrical Code addresses these under specific circumstances primarily related to motor circuits and industrial applications. An instantaneous strip circuit breaker is designed to trip very quickly in response to a high-level fault current, providing rapid protection against short circuits and other electrical faults. The use of instantaneous strip breakers is often coordinated with other protective devices in the electrical system to ensure selective coordination and minimize nuisance tripping. Firstly, instantaneous strip circuit breakers are commonly used in motor circuits to provide short-circuit protection for the motor windings and associated conductors. The National Electrical Code specifies requirements for the selection and coordination of motor circuit protection devices, including instantaneous strip breakers, to ensure that the motor is adequately protected against overcurrent and fault conditions. Secondly, in industrial applications, instantaneous strip breakers may be used to protect critical equipment and processes from damage due to electrical faults. These breakers are typically coordinated with other protective devices, such as fuses or molded case circuit breakers, to provide a layered approach to overcurrent protection. Thirdly, the National Electrical Code provides guidance on the selection and application of instantaneous strip breakers in various types of electrical systems. Section 240.83 of the National Electrical Code addresses the marking requirements for instantaneous strip circuit breakers, specifying that they must be clearly marked with the instantaneous strip current rating. Fourthly, when using instantaneous strip breakers, it is essential to perform a coordination study to ensure that the breakers are properly coordinated with other protective devices in the electrical system. A coordination study involves analyzing the time current characteristics of all protective devices in the system to ensure that the breaker closest to the fault will trip first, minimizing the impact of the fault on the rest of the system. Fifthly, instantaneous strip breakers are not typically used in residential or commercial branch circuits due to the potential for nuisance tripping. In these applications, inverse time circuit breakers, which have a time delay that varies inversely with the magnitude of the overcurrent, are generally preferred. Sixthly, the National Electrical Code requires that instantaneous strip breakers be installed in readily accessible locations to allow for easy inspection, testing, and maintenance. The breakers should also be protected from physical damage and environmental factors that could affect their performance. Seventhly, regular testing and maintenance of instantaneous strip breakers are essential to ensure that they will operate correctly when needed. Testing should include verifying the breaker's instantaneous strip current rating and its ability to interrupt fault currents safely. Eighthly, when replacing an instantaneous strip breaker, it is important to select a replacement breaker with the same or higher interrupting rating and instantaneous strip current rating. The replacement breaker should also be compatible with the existing electrical system and meet all applicable code requirements. Ninthly, always follow the manufacturer's instructions and recommendations when installing, testing, or maintaining instantaneous strip breakers. The manufacturer's instructions provide valuable information on the proper application, operation, and maintenance of the breakers. Tenthly, consult with a qualified electrical engineer or other subject matter expert for guidance on the selection, coordination, and application of instantaneous strip breakers in complex electrical systems. An expert can help ensure that the breakers are properly sized and coordinated to provide adequate protection for the electrical system and its components. In the specific scenario of a 30 amps 208 volts receptacle single-phase circuit, the decision to use an instantaneous strip breaker would depend on the intended use of the receptacle, the characteristics of the connected equipment, and the overall electrical system design. If the receptacle is intended to serve sensitive electronic equipment or equipment that is susceptible to damage from voltage transients, an instantaneous strip breaker may be beneficial. However, if the receptacle is intended to serve general-purpose loads, an inverse time circuit breaker may be more appropriate. Ultimately, the decision to use an instantaneous strip breaker or an inverse time circuit breaker should be based on a thorough evaluation of the electrical system requirements and the careful consideration of the potential risks and benefits.